Okay, welcome back, everyone. This week, what we're going to do is we are going to extend the idea of factoring, and we're going to focus solely on something called quadratics. And we're going to focus on quadratic equations. And what you can see here is a graph of a quadratic equation. And a quadratic equation, if you remember from the last unit, is ax squared plus bx plus c equals 0. Now, the equals 0 is the new part because we looked at expressions before. Now we're turning them into equations by adding the equals 0 part. So every single quadratic equation should look like that. You should have a squared term, an x term, and then a constant of some sort, and then it's always going to be equal to 0. So that's something really important that we need to remember, is that we're going to always have equal to 0. So that's why I highlighted it here. You might see some that aren't equal to 0, and you just have to make them equal to 0 by adding or subtracting whatever is on that right-hand side and ending up with a 0 there. So the part that's highlighted in yellow here in the next paragraph, it says the solutions to a quadratic equation are the points where the graph crosses the x-axis. All right, so one of the key things here is solutions. There is going to be more than one solution to a quadratic equation. It's true for most quadratic equations, but not all quadratic equations. And the reason is because if you look at this graph of a quadratic equation, you can see it starts on the left-hand side and it's coming down on the left-hand side, and it crosses the x-axis there, but then it gets to a point where it stops and it turns back around and it heads back up. All right, and the reason is because we have a squared term in there, and when we square things, it takes the negative and makes it positive, and so things are going to start to flip around with the squared term. And you can also see that there's a slight curve to this graph, and that is also because of the squared term. The squared term causes the graph to curve, and it gradually gets steeper and steeper and steeper. And that is because we're squaring numbers, and when we square numbers, they get bigger faster. All right, so what else do I need to talk about? I was going to mention something, and I just totally forgot. There's two solutions because it crosses the x-axis at 2 points. It's possible for a quadratic equation to only have one solution, and that would happen if the quadratic equation, if the very bottom of the quadratic equation was on the x-axis. All right. So how do we solve these? Well, we solve them by factoring, ideally. I would always suggest trying factoring first because it's the easiest thing we have to do. The next lesson for this week, we're going to talk about using the quadratic formula, and the quadratic formula it has a whole bunch of operations in it, including square roots, plus or minus, all kinds of different things. And there's all kinds of chances to make some sort of mistake using the quadratic formula. So if you can factor it, I would always factor it first. All right, so we should know how to factor a trinomial with a squared term and an x term and a constant. And if we look at these, we can start to figure this out. All right, let me see here. I'm just looking at this wondering, I think I'm missing something. But all right, we're going to keep this pretty simple, I guess. All right. So to solve these quadratics by factoring, what we just need to do is what we know how to do. We list all the factors of the C term, right? We look at what adds to the B term, and then we write the binomials in factored form. And you can see we've kind of started the process here with this first example where we have x squared minus 15x plus 50 equals 0. We're going to look for two numbers that multiply to equal 50 and add to equal negative 15. And you can see all the factors are listed there. And in red, you can see it says if you can remember the negatives, you don't have to list them. So it can be kind of a pain to list everything, positive and negative. But if you can just remember the negatives, you don't have to write them down. So we're looking at 50 and adding to negative 15. So we're going to say, all right, I know that 5 and 10 add to 15, but I know they need to be negative 5 and negative 10, right? So negative 5 and negative 10 are the two numbers that add to 15. So if I add those together, they add to negative 15. And so the factored form is going to look slightly different than what we've done in the past. We're still going to make two binomials where we have x minus 5, x minus 10, but we have to add that equals 0 because if you look back up here in our original equation, it says equals 0. So we want to make sure we bring that along. We want to make sure we have an equation, basically. All right, and then the solution is whatever makes this equation true. Okay, so when I say that, what I mean is we need to make either the first binomial 0, because 0 times the second binomial would be equal to 0, or we need to make the second binomial 0, so that 0 times the first binomial would then be equal to 0. So the way we do that is we just look at it and say, all right, x minus 5 equals 0, and then we just solve that for x. And so I'm just going to add 5. So x is equal to 5. All right, and then for the second one, it's x minus 10 is equal to 0. Now, I'm including the parentheses here, and you really wouldn't have to. They might actually just get in the way, so you don't necessarily have to use those. So x is equal to 10. So my solutions are x is 5 and x is 10. And typically I want to write them as a point because if you remember from up above, it's the point where the graph crosses the x-axis, right? And so that point is going to be 5, 0 and 10, 0. Okay, so my solutions are 5, 0 and 10, 0. All right, and hopefully you notice that you don't necessarily have to do all this work that I did underneath where it says solution. You don't have to set those equal to 0 and solve for x because you can just look at the factored form and say, hey, if it's x minus 5 and x minus 10, my solutions are just going to be the opposite. They're going to be positive 5 and positive 10. All right, so that's kind of a shortcut that we can use to make our lives a little bit simpler. Okay, so let's look at another one here. So in this case, we have x squared plus 11x plus 10 equals 0. The factors are listed there for 10. We look at the ones that add to 10. Well, in this case, it's just 1 and 10. And because 1 plus 10 is equal to 11. So the factored form is x plus 1 and x plus 10 equals 0. And so here for my solutions, I'm not going to bother with doing all the extra work for my solutions. I'm just going to write negative 1, 0 and negative 10, 0 and put a box around it because those are the opposites of 1 and 10. Okay, so the solutions are always the opposite of the two numbers. And it says that there in the problem, right? All right, another one. X squared plus 3x minus 18 equals 0. So this is one where we have a minus 18, so it's negative. So we've got to remember negatives here. And so in this case, instead of looking for something that adds to the number 3, we're going to have to look at something that has a difference of 3. And we can see the 3 times 6 has a difference of 3. And so when I say add to 3 here in the next column, it's going to be 6 plus negative 3. Okay, or you could do 6 minus 3, I guess, but to honor the spirit of adding, we're adding a negative 3 to the 6, right? And so that equals 3. And so our factored form is going to be x plus 6, x minus 3 equals 0. Make that a little better, 0. And so then just to do the same thing that we just did, instead of going through the work of setting up the little equations, we can just say, hey, it's a positive 6 and a negative 3. So it's going to be a negative 6 and a positive 3. So we have negative 6, 0 and 3, 0. All right, so fairly simple way to start off the week. I know some of you have the ACT exam, so that's why we're keeping it a little bit simpler. So you got 8 problems here, and they should be pretty quick for you to get through. So this is a little different than what we've done in the past. The assignment's actually attached right here, so you are going to submit this as the assignment as well. All right, so you got your notes, and then you got your assignment here. Whoops. So if you have any questions, let me know. Otherwise, make sure you submit this in Schoology.